What if I told you that one of Japan's most extraordinary highways does not simply cross Tokyo Bay, it disappears beneath it? Deep below the water, two enormous tunnels carry thousands of vehicles through the seabed. In the middle of the bay, the road rises onto an artificial island. Then, as if emerging from another world, it continues across a vast bridge toward the opposite shore. This is the Tokyo Bay Aqua Line, a project that transformed an almost impossible vision into one of the greatest marine engineering achievements ever built. Before the Aqua Line existed, traveling between Kawasaki and Kisarazu meant driving around the entire shoreline of Tokyo Bay. The journey was long, crowded, and inefficient. Japanese engineers imagined a more direct connection, a route running straight across the bay. But Tokyo Bay is not an easy place to build. The seabed contains soft soil. The water is busy with commercial shipping. The region is exposed to strong winds, earthquakes, high waves, and severe coastal weather. A conventional bridge across the entire bay could have interfered with major shipping routes and aviation operations near Tokyo. The solution was remarkable. Instead of choosing only a bridge or only a tunnel, engineers combined both. From the Kawasaki side, the expressway enters two shield-bored tunnels extending beneath the seabed. These parallel tubes form the Aqua Tunnel, carrying traffic safely below one of Japan's busiest bodies of water. To construct them, engineers first created enormous launch facilities near Ukishima. Inside these deep chambers, giant tunnel-boring machines were assembled piece by piece. Their steel shields, cutter heads, backup gantries, power systems, conveyor equipment, and segment-handling machinery were lowered underground and carefully connected. Then the excavation began. The cutter heads rotated against the ground, while pressurized shields protected the tunnel face. Excavated material moved through conveyors, and behind each machine, workers installed curved precast concrete segments. Segment by segment, ring by ring, the twin tunnels advanced beneath Tokyo Bay. Every movement had to be controlled with extraordinary precision. The machines needed to maintain the correct direction, pressure, depth, and alignment, while resisting groundwater and unstable marine soil. Behind the completed lining rings, grout was injected to fill the space between the concrete tunnel and the surrounding ground. Slowly, two permanent underground passageways appeared, where previously there had been only sediment and seawater. Above the tunnels stands one of the route's most distinctive structures, Kaze no To, the Tower of Wind. This artificial ventilation island was built in the open bay to support the tunnel's airflow and safety systems. Beneath its visible towers lies major infrastructure connected to the underground expressway. Farther east, engineers created another artificial island, Umihotaru. Building an island in Tokyo Bay required an enormous sequence of marine operations. The seabed was dredged and improved. Perimeter structures were installed. Rock, sand, and engineered fill were placed inside the protected boundary. Revetments and armor units defended the new land against waves and erosion. Settlement was monitored carefully before permanent construction could begin. Umihotaru became the transition point where the underwater tunnel rises toward the surface and connects with the bridge. Today, it also serves as a spectacular rest area surrounded by water, offering panoramic views across Tokyo Bay. But beneath its public spaces is a highly engineered transportation junction linking the tunnel, ventilation systems, roadways, and bridge. From Umihotaru, the Aqua Line continues toward Kisarazu on the Aqua Bridge. Its offshore foundations were built from groups of steel tubular piles driven deep into the seabed. Cofferdams created temporary dry construction zones around the piles. Reinforced concrete pile caps, columns, pier heads, and bearings were then completed above the water. Large steel box girder sections arrived by barge. Floating cranes lifted these massive components from the sea and positioned them onto the bridge piers. Each segment had to be aligned and secured before it could be connected to the next. Gradually, isolated pieces became a continuous bridge stretching across the bay. After the main civil structures were complete, another complex stage began. Ventilation ducts, electrical cables, tunnel lighting, jet fans, Fire water systems, drainage, communication equipment, safety devices, and road surfaces were installed. Every component had to work as part of one integrated system. Before public traffic was allowed onto the route, engineers performed controlled tests. Ventilation fans were activated. Lighting and electrical systems were verified. Inspection vehicles traveled through the tunnels, across Umihotaru, and along the bridge. Only after the entire corridor passed its safety and operational checks was the Tokyo Bay Aqua Line ready to open. Today, vehicles travel through it in bright sunshine, heavy rain, strong coastal wind, dense morning fog, summer heat, and complete darkness. Inside the tunnel, powerful ventilation and lighting systems operate continuously. Above the water, the bridge carries traffic, while ships move safely through Tokyo Bay. At Umihotaru, travelers can stop in the middle of the sea and look back at the route they have just crossed. The Tokyo Bay Aqua Line is more than a highway. It is a tunnel beneath the ocean. It is an artificial island created from the seabed. It is a bridge assembled above open water. And it is proof that when engineering, precision, and human ambition come together, even the sea itself can become part of the road. This is not simply a connection between Kawasaki and Kisarazu. This is the moment Japan built a highway through Tokyo Bay.